All right, so at the beginning of problem 7, I said I would do it two ways, and then I stopped the video and realized, hey, I didn't show you that I could factor this, so I made a version 2 of this. Now, remember, I still have to look at the factors of my constant term, the factors of 27, plus or minus 1, 3, 9, and 27. The factors of 1 plus or minus 1. But rather than go through, and let's list it, they wanted that list. And remember, this is my possible numerators, this is my possible denominator. So 1 divided by 1 is just 1, 3 divided by 1 is 3, 9 divided by 1, and 27 divided by 1. And then I went through in the last video and checked each one of these. Well, they wanted this list, but I can get away without using this list because of my factoring abilities. This is quadratic in form, and I know that x squared times x squared is x to the fourth. And if you want two numbers that multiply together to give you positive 27, but add to get a negative 12, this negative 9 and negative 3 will do the trick. And x squared minus 9 factors to x plus 3 and x minus 3. But x squared minus 3 doesn't factor. 3 is not a perfect square. And if I solve this equation, I get negative 3, positive 3. And over here, I can solve it, but they're not asking for it because when I take the square root of each side, this is not a rational number. They were wanting rational solutions. They were wanting these two. Well, look at 3 and negative 3. That's in my list. There it is. I knew that if there were rational numbers, they were going to appear in this list. So anyway, there's an alternative way to get the answers for number 7 that I think is a little bit easier because, I recognized that I could factor it. So I hope that helps.